Okay, so our next step is to look at some properties of matrix multiplication. Let's go. So the first property we have already looked at is the property that A times B in general is not equal to B times A. Yeah, so multiplication is not commutative. And this is the only property that is different from normal multiplication of scalars. The other properties are the same as if you had scalars. Okay, so for example, you have this property, matrix A times, open parenthesis, matrix B plus C. You can write this as matrix A times matrix B plus matrix A times matrix C. But you have to be careful with the order of the operations. So for example, if you did matrix B plus matrix C times matrix A, that would be equal to matrix B times matrix A plus matrix C times matrix A. So be careful, because multiplying on the left means that you have to multiply on the left everywhere, while multiplying on the right means that you have to multiply on the right everywhere. Okay? But apart from this is identical to multiplication of scalars. And these are called the distributive property. Distributive properties. Then we have also that if you have a scalar, so for example, a scalar lambda times A plus B, where A and B are matrices, then you can also do this, lambda times A plus lambda times B. Yeah. And since lambda is a scalar, it wouldn't matter if it's on the right or if it's on the left, because scalars can move around. Okay. Next, we have the associative properties, which are the following. A multiplied by matrix B multiplied by C, that's equal to matrix A multiplied by B and the result multiplied by matrix C. And what we do is that we usually just write it A times B times C. So it doesn't matter if you first multiply A and B together and then C, or if you multiply B and C together and then A. The result is the same. Okay? So this is called the associative property. And it also works with scalars. So for example, if you have A times a matrix which is lambda times C, where lambda is a scalar, then this is equal to lambda times matrix A times B times C. Yeah? So the scalar can always move around. It doesn't matter. So remember, this is lambda is a scalar. Can move around. Okay. So how to remember these properties? Just a very simple rule. The same properties as when you are multiplying scalars, but whenever the multiplication is on the left, you have to keep it on the left. And whenever the multiplication of a matrix is on the right, you have to keep it always on the right. Because of the first property here, that the multiplication is not commutative in general. Okay? Let's do an example to show you how this would work. So here I write an equation in which A, B, C are matrices. That's why I'm using uppercase letters. Yeah, so let me A, B, C are matrices. All of these matrices. And then the lowercase things, which are X, Y. So these are vectors. Okay? So here I have written an equation that involves matrices and it involves vectors. Notice there's one thing you haven't seen yet, which is the A squared here. So A squared just means A times A. Okay? So the question is solve for vector X. So before doing this, let me show you what this would like if these were scalars. So imagine A, B, C, X, and Y were numbers, single numbers. Yeah. So then the equation would look like this: A times bx plus cy equals a squared cax plus cax. Yeah, that's what it would look like. And now if you had to solve for x, how would you do it? First, you would expand the parentheses. abx plus acy equals a squared cax plus cax. Now you would factor out the x's, yeah? So that you could put all the x's on the same side. So first, let's factor out the x's. abx plus acy equals, and now you have x everywhere, so you could do, this is a squared plus 1 cax, yeah? Now you put all the x's on the same side, changing the sign. So you would do abx minus a squared plus 1 cax equals minus acy. Now we can still factorize the x on the left. So we could do bracket ab minus a squared plus 1 ca times x equal minus acy. And now we would be ready to just obtain x by doing minus acy divided by ab minus a squared plus 1 ca. So this, you are so used to it because you have done it for so long now. You have been studying maths for very long. So you do this automatically. You don't have to think about apply the distributive property, apply the associative property, right? You just do it. You factorize things out, you put on the other side, and so on. So the aim here that I have is that you are able to do the same thing with matrices, okay? And the only thing you will have to be careful about is to remember if a matrix is multiplying on the left or on the right. But otherwise, everything is the same. So let's see how this would look like, okay? So we start with our equation. Matrix A times parentheses matrix B vector x plus matrix C vector y equals matrix A squared times matrix C times matrix A times vector x plus matrix C times matrix A times vector x. Okay, so now we do the same steps that we did on the right, actually. Yeah. So first we expand this parenthesis because this is one of the properties. So we do A times B vector x plus A times C vector y equals the right hand side. Okay. Now we can factorize the right hand side. Yeah. So what do we do? How do we factorize this cax? We do a squared plus 1 times cax. But wait a second. What do you mean a squared plus 1? Plus 1? I mean, A is a matrix. A squared is A times A, which is a matrix. Okay, so we have some sort of matrix. I don't even know which size. How do I do plus 1? So remember, we already see this in one example when we were doing the scaling matrix. And we said, what is the matrix that scales all vectors by 1? So it leaves every vector as it is. So there is a matrix called the identity matrix such that I times x equals x. And this is equivalent to multiplying times 1. 1 times a scalar x equals the same scalar x. Okay. So in the matrix world, you don't use ones. You use i's. The identity matrix. Okay. So that's our identity matrix I. Okay, next we move all the x's to one side. So we do abx minus a squared plus I cax equals minus acy. Now we factor out the x on the left. So we do ab minus a squared plus I times ca x equals minus acy. And now there will be a last step, which I haven't told you about, which is the equivalent of division. So let's say that we call, so now this left-hand side between square brackets, this would be a matrix, right? It would be matrix A times matrix B, that's a matrix, and then a squared plus I is another matrix, times C times A is a matrix. You subtract those two matrices. So the end result is a matrix. So let's call it M. Okay. So we would say that now we have M times vector X equals minus AC times vector Y. So we cannot do something like this, divided by M. That does not exist. You cannot divide matrices, okay? However, what you can do is you can multiply on the left by a matrix which is called the inverse of M, which we will see in detail later. And the property of this inverse is that when you multiply the inverse times the matrix, you end up with I. Yeah, so that's the same as dividing. Yeah, but you have to be careful because you are dividing on the left. So you are multiplying by the inverse on the left. So if you multiply the left-hand side of this equation by the inverse on the left, you have to remember to multiply the left-hand side of the equation on the right by the inverse, but also on the left. So now we would have x equals the minus inverse of m, which is all this big thing. So all this thing, you do the inverse, and then you do times a times c times vector y. And this way you would have solved for your vector x. Okay? So it's really similar to what we were doing with scalars, yeah? But the key differences were using I instead of 1, using the inverse instead of the division, and remember that you always keep, if A here is multiplying this on the left, you always keep A on the left, yeah? And the same would be, so if CA here is multiplying on the right, you always keep it on the right, okay? And that's it. Thanks for listening.